Exponential growth is one of the most accurate ways of finding out the rate in which an amount will grow in a certain period of time and how continuously. We explain and use the Chernobyl incident as an example to show how it works and try to figure out the amount of nuclear waste spread throughout the world. Exponential growth occurs when the growth rate of a value is proportional to the function's current value. The main formula for calculating this growth is the following. In this formula, P stands for the initial quantity, R is the rate at which it grows, T is the time in which it grows, generally measured in years, and A is the final quantity acquired after the calculation. This formula changes when there is a compound interest. In this formula, N represents the times compounded per year. When it is compounded continuously, the formula changes to... The following is an example of a graph of exponential growth with a domain of infinity, a range from 0 to infinity, and a reference point of 1, 0. In this graph, Y is the amount of neutrons released during fission, and X is the amount of chain reactions.
The USSR needed a cheap way of getting energy. Their solution was nuclear power. On April 25th of 1986 in Chernobyl, Ukraine, they made a 4 nuclear reactor. In there, 1 kilogram of uranium produced the same amount of energy as 3 million kilograms of coal. Using uranium to produce energy is the cheapest way, yet it must be very precise. One night, the workers there were asked to carry a safety drill. They wanted to see if the plant could keep running until backup generators could kick in. At 12:05 a.m. test started, and around 20 minutes later it kept going. 3 minutes later something went wrong. The energy levels were lowered immensely, but they managed to keep it under control. At 1 a.m. they let water flow in too fast, and not all of it could be turned into steam. Yet they managed to keep it controlled again. Due to the methods they were using to try and keep the steam levels under control, the core started heating up to dangerous levels. Unaware of this, the people in charge of the safety test gave the signal to start the test and shut down the turbines. But the pressure in the reactor was critical. The heat of the reactor reached levels 100 times stronger than usual. The heat destroyed the core, and at 1:24 a.m. the 4th reactor exploded. The explosion killed 31 people inside at the time. 69 firemen arrived to try and reduce the damage, but 31 of them died from exposure to the radiation. The nearest city there was Pripyat. Due to the events at Chernobyl, the government asked the residents to evacuate the city immediately. At 5 p.m., Pripyat had been completely evacuated. 10 days later, the toxic cloud had reached US and Japan. After the explosion, scientists went to investigate what happened, so they entered the core. The scientists saw that the core was overheated and there wasn't enough water to keep it under control. The radiation was very powerful and it spread quickly. The USSR was forced to modify their reactors so a disaster wouldn't be able to repeat itself.
One similar real-life example is the Fukushima Daiichi nuclear disaster that occurred on March 2011 in Japan. Due to recent earthquakes and tsunamis, the emergency generators cooling the reactors were destroyed, causing 3 nuclear meltdowns, causing the release of radioactive material and various hydrogen plus air explosions. Another similar real-life example is the incident in Russia on April 1993, when a tank at the Tomsk 7 exploded when it was being cleaned with nitric acid, releasing a massive cloud of radioactive gas.
For the conclusion, I will be speaking about exponential growth and some details about nuclear energy. Exponential growth is development at an increasingly fast rate in proportion to the growing total number. It consists of getting a number or amount depending on the time, rate, and method of compounding, giving us a clear result of how whatever is being measured is going to be growing in the future, or how it grew from the past. Exponential decay is a quantity that decreases its proportional rate to its current value. The implications of using nuclear energy is it's a cheaper method of making energy, but it can lead to very catastrophic events if a mistake is made. We do not consider this energy to be clean due to the danger of, if you make a simple mistake, a disastrous outcome could come to not only us as people, but to the world as a whole. There is a nuclear energy plant in Mexico, in Alto Lucero, Veracruz, and we don't think it's safe. A mistake can affect all of our lives dramatically in more ways than one. For the Chernobyl nuclear disaster in 1986, maybe they really should have been more careful, or at least aware of each other's actions as they were trying to take back control of the nuclear reactor and communicate better. After what they did, there wasn't any way to stop the nuclear energy from spreading, but they could have decreased the amount that got out. This incident caused many deaths and illnesses all throughout the world. Many animals and plants died and mutated due to radiation exposure. Global warming was heavily affected and sped up dramatically, and the exposure to radiation doesn't just affect people who are exposed to it, but their offspring and children and future generations as well. Nuclear waste can be catastrophically dangerous to us and the environment as a whole, even causing mutations in the living things on our planet. You really feel like we need to be aware of the catastrophic events that could come from using nuclear energy, so it should really be used to a minimum or only as a last resort.